So question 10, which is related to the chemical reactions, the rate. The student investigate the rate of reaction between nitric acid and a lump of magnesium carbonate and the apparatus shown. So when magnesium carbonate react with nitric acid, it will give salt, water, and carbon dioxide. So as the gas escape, the mass of the content in the flask will decrease. So we can measure the change in mass over time to get the rate or speed of this reaction. Lumps of magnesium carbonate were added into a conical flask. 40 cm cube of a nitric acid was then poured, and a conical flask using a measuring cylinder. Then magnesium carbonate was in excess. The conical flask was placed on the balance and the cotton wool was placed. The purpose of a cotton wool, it prevent the reaction mixture to escape. The mass of a conical flask and in content was measured and a time was started. The mass of conical flask and the content were measured every minute for 7 minutes. Like we measure after every minute and continue for 7 minutes. So use the diagram to complete. So you have this one is the mass of a content in the beginning. Like here, mass of a conical flask and its content and the total mass loss. This is at the beginning, the experiment. So you can use the screen annotation to complete this. The first one is 86.0. The second one is 85.0. 84.4. Yeah, that's right. Then 84 point, it's 84.1, I guess. This is because it is between, this point is, it is between 84.2 and 84. So that is 84.1. Next, 80, no, it's below, it's below 84. It cannot be. This is 83.9. It is below 84, like 1 point below. Each point is representing 0.1. So this is 83.9. This is also 83.9 and 83.9. Now, we have to calculate the difference in the masses. So in the beginning, when experiment is started, like there's no difference in the mass. In the beginning, so change in mass is 0. Then 86, like we started at 86 and now it is 85. So difference in mass is 1.0. Then this is 84.6 and beginning it was 86. So how much mass has decreased? So 86 minus 84.4. So that's equal to 1.6. This will be 86 minus 84.1. So 1.9. This will be 2.0. This will be 2.1, 2.1 and 2.1. So we have the change in masses 0, 1, 1.6, 1.9, 2, 2.1, 2.1 and 2.1. Why the mass does not change for the last part? It shows that the reaction has completed. There's no more further reaction. That's why the mass does not change. The next one, plot the results on the grid and draw a smooth line graph. So we have the total change in mass and the experiment, like 7 experiments are done. So in the beginning, because this one is representing the time, like in the beginning, this is starting with 0 and ending at 7. So at 0, it was 0, the change lost mass. After 1, it was 1. Then after 2, it was 1.6. 2 boxes equals to 0.1. So one box is like 0.05 for y-axis. So this is 1.5 and the 2 boxes above will be 1.6. Then at 3, it is 1.9. So 2 boxes below 1, 2 boxes below 2. Then we have at 4, it is 2.1. So this one is representing 2 and this is 2.1. And then at 5 also 2.1. Six also it is 2.1 and 7 it is also 2.1. So last three values are 2. This was 2. So you have to draw a smooth line graph. The next part, the average rate of a reaction can be calculated using the equation, the total loss mass divided by time. Calculate the average rate for first 30 seconds. So you can use your graph or you can also use the, so for first 30 seconds, because like this is minutes. So like this is 60 seconds. 1 minute equals to 60 seconds. So 30 seconds will be in between or 0.5 minute. So this is 0.5 minutes or equals to 30 seconds. So we'll draw a line and find how much mass has changed. Each box is representing two boxes equals to 0.1. So this will be 0.6 and this will be 0.65. So this is the total loss mass is 0.65. And the total time that is 30. So 0.65 divided by 30, what's the answer? 0.65 divided by 30. You have to show this on your graph as well.
0.021.
So 0.021. So we write 0.021 and the unit, because unit of mass is gram and unit of time is second, so it is gram per second. So if mass is given if mass was given and time interval was there, so it will be, time can be in minutes, it can be second. If it is minutes, so gram per minute, but as it is in seconds, so gram per second. Then the experiment was repeated using an excess of a magnesium carbonate and this all other condition. Sketch on the graph you expect.
More
So
steeper.
in the beginning, if you check,
It was also excess in beginning, but
yeah,
I
it was,
think not powdered.
yeah, that's right. So the basic idea is that it was already in excess. In the beginning, it was in excess. So the reaction rate will be faster, but the final
But
product does not.
same as
Same
fine.
mass. So final mass, or it will complete in a short time, but the final mass will be 2.1. So this will be the graph at for which part? This is for part D. Then in part E, why does the mass of a conical flask and content decreases? What's the
Gas
reason?
produced escapes from the cotton wool
So
along the
yeah,
cotton wool.
gas escape.
Carbon dioxide escapes.
So the gas which is produced escape. That's why the mass or carbon dioxide given off that escape suggests the purpose of a cotton wool. If some student
To
usually,
prevent acid spray.
yeah, good. Some student just mentioned to allow the gas to escape. That is totally wrong because, for example, if I don't have the cotton wool there, even the gas will escape. It won't make difference if there's a cotton wool or no. If there was a stopper, then yes, it will make a difference. But what if a student is not using a cotton wool and doing the experiment, the gas will still escape. So it won't make difference if there is a cotton wool or no. The main purpose of the cotton wool is to prevent the acid spray, like or preventing the content in the flask to escape, so that this acid cannot escape from the reaction mixture. Otherwise, the change in mass will be much greater or higher. So don't say that allow the gas to escape. Just mention that like preventing loss of acid. Why the and after mentioning preventing loss of acid or acid spray, then only allow the gas to escape or carbon dioxide. Why does the graph level of explain your answer? Why the graph
No gas is being produced as reaction stopped.
or limiting reagent used up or hydrochloric, which acid was there?
Yes.
So acid used up, limiting reagent used up, reaction stops, limiting reagent used up. The purpose of the cotton wool, why the graph level off, what does it mean? Like why the graph become horizontal or the slope is zero? They're saying why the graph level off means what is the reason for this part, what it shows. It shows that the reaction stopped. And why the reaction stops? Because at this point, one of the reagent or the limiting reagent used up. That's why if you have a change in mass in time or a volume in time, the graph always level off shows that the reaction has stopped. And why the reaction stopped? Because the limiting reagent or one of the reagent used up. So these are some experiment questions from classified paper 6.